for letting me come talk to your class. As Ms. Williams mentioned, my name is Carl Coe. I work for a company called Parametric Technology Corporation, PTC. What we do is we work with companies all over the world that design and manufacture the products that we use every day, everything from lamps to cars to airplanes to clothing, anything you could possibly imagine. Our software helps companies design and manufacture and collaborate with their suppliers, and then lastly, manage the configuration of their products throughout their entire life cycle. So what I thought I would talk to you a little bit about today are a few programs. I'm responsible for our aerospace and defense market in North America. So I get the pleasure of working with on some really, really cool projects right now. In particular, I have the first one mentioned, NASA Constellation. NASA is replacing the space shuttle with a new program called the Constellation Program that is a 50-year program with everything from mission back to the moon and mission to Mars. And as you might imagine, there's a lot of complexity involved in that, and I'm fortunate enough to work on that. Another one that I wanted to make mention of is a company called Force Protection. They're down in Ladson, South Carolina, down near Charleston, and they have created an armored vehicle that is saving a lot of lives in Iraq and Afghanistan right now, and it's a really neat story. I'll talk about that a little bit. A company called Bombardier. You may know Bombardier. They make aircraft primarily. They're based in Montreal, Canada. I spend a lot of time in Montreal. Bombardier, they have a new aircraft called the C-Series that is, they're trying to make it a much, much more efficient airplane to fly, a lot less expensive, using a lot less fuel. And then finally, Lockheed Martin LCS, which is a new ship designed to not have as many people. You don't need as many people on the ship. It's nearly all electronic. So I'll talk about those 4 programs. And then finally, there's something that we're involved in, my company's involved in heavily, called the FIRST program. It stands for the Inspiration and Recognition of Science and Technology. And it's for students like you to get involved in design projects early so that you can have a lot of fun, compete with your peers, and design some pretty cool stuff. I think you have a robotic team here at Cary Academy, and so this might be a precursor to that. So with that, I'll jump into it. Any questions? Feel free to jump in any time with questions. I'm very informal, and I'll be happy to answer anything I can. As I mentioned, we work with companies virtually that design and manufacture anything. This is a list of just a few of our customers, some names that I'm sure you're familiar with. Reebok, Toyota, Dell, Apple, you name it. All their products are designed using our software every day. So we get to have a lot of fun working on some really cool programs. On the far left, it's aerospace and defense. That's where I spend my day. My team and I are responsible for Boeing and NASA and the U.S. Navy and Lockheed Martin and the Army. And again, as I mentioned, we work on a lot of really cool programs. The thing that I wanted to help give you a sense of is what process do these companies go through when they design their products? How does it come to bear? How does it happen? And really, the way companies decide to design products, there might be a market need for something. They may have an evolution of a previous product. But the first thing that any of these companies or organizations have to have is a set of requirements that say, all right, if we're going to create the new space shuttle replacement, what do we want it to do? What does it need to be able to do? And so those requirements define everything going forward. And as requirements change, your design changes, etc. So I'll refer back to requirements a lot. But once you go from requirements, then you go through a conceptual design, just concepts, not where you're putting actual dimensions, like really, in your world, I don't know if this would make a lot of sense, but really tight dimensions, very specific dimensions that says this part or this product has to meet these exact specifications for design. This is before that. This is just concept where you're sort of sketching ideas of what you might want something to look like and what you might want it to be. Once you get through that concept design phase, then you get into detailed design phase where you really put the specifics around a particular product to make sure that it meets, that it has to be very, very specific in terms of its dimensions. From there, you go into manufacture, where you would go into analysis, where you use software tools to analyze the quality and will this work under specific conditions. If it's a car and it's hitting speed bumps and it's rattling, what if it hits those particular conditions, what part of the car might break, for example. So they analyze that. Then they go into manufacturing and so on and so on. So I just want to give you a little bit of idea. Regardless of the product that these companies make, that's essentially the process that they go to. But it really starts first and foremost with requirements, and then from there, the concept, and then it's all about the math, which you guys are working on in this class. It really, at the end of the day, it all comes down to the math. The brains behind how all of this gets done, the math defines all of it. So it's really important what you're studying in class. So talk a little bit about the Constellation Program. First off, this is really cool. I mean, it is. I've been lucky enough to be on the launch pad at Cape Canaveral in Florida, where they launched the space shuttle, and it's like nothing you have ever seen in your life. The magnitude, the size of everything is mind-boggling. The building that they keep the space shuttle in is so large that it has its own weather inside. It develops, condensation develops, and clouds build in the top of the building. It is that big. So just nothing else. It's cool to work on. The Constellation Program is the next generation space transportation system. It's going to cover a wide range of missions. Everything, as I mentioned, from a vehicle to get to the International Space Station, a vehicle to get back to the moon, and then finally, believe it or not, a vehicle. This is the vehicle they expect to take us to Mars and even beyond. So this is a 50-year program minimum. So as you sit here and think about the Constellation Program, this could be something that you would actually, when you go out into the world after college and go to work, this is a program that you very well potentially could work on. In fact, 10 years from now, it still really will be in its relative infancy. So it's a long-running program, billions and billions and billions of dollars. As I mentioned, it's replacing the space shuttle. It's a 50-year program. There are literally hundreds of companies across the world and thousands upon thousands of people that are designing different parts of the Constellation Program. This element of the Constellation Program is called Orion, and in the middle of Orion is the crew exploration vehicle. This is where the astronauts would be. But as I mentioned, there are hundreds and thousands of people working on little different pieces. I work with Hamilton Sunstrand in Connecticut. They're designing the spacesuit for the Constellation Program. The design of the spacesuit itself involves thousands of different people, believe it or not, and the spacesuit is over $1 million per suit. So it's just really highly complex. And the reason I want to make that point, and I actually saw it over here on your board, collaboration. In our world today, and the way that all these products are designed, and each of the examples that I'm going to talk to you about, collaboration is so unbelievably critical. The ability for you to be able to interrelate and get along with the people that are on your broader design team, the technology that it takes to manage all that collaborative data that's going all over the globe, the ability to work in teams, etc., is more and more and more important than it ever has been. So every single program I work on, collaboration and the ability to work in teams is critical. So I'm sure you're getting a lot of that here at school. Any questions on Constellation? Move on to the next one. So this is a company sort of near and dear to my heart that I spend a lot of time with. It's called Force Protection, as I mentioned. Oh, I have a question? Yeah, sure.
When did it start? When did it begin?
The Constellation Program? It's a very good question. They announced in 2003, so 8 years ago, that they were going to end of life. They were going to end the space shuttle, and so from that point forward, they've really been working heavily on Constellation. It was named a program in 2005. And from 2005 to now, they've been putting a lot of work in. And the first, as I mentioned, the first element of the Constellation program is called the CEV, the Crew Exploration Vehicle. And that vehicle will take them to the International Space Station. And they hope to have that launched for the first time 2014. So from the time they announced the space shuttle would no longer be in 2003 to the first flight, will have 11 years.
Do you know by any chance what powers the engines on the thing?
Yeah, well, it's the same powering mechanism they use on the space shuttle. In fact, I had some slides on that and I took them out because I didn't know if I would get enough time. But it's rocket jet propulsion, just like on the space shuttle.
You know how many astronauts will go up?
Well, hopefully, it depends. If in this particular vehicle, only 4 at a time. But this is just the very first variation of what will be coming. So the idea here is to be able to shuttle people back and forth to the International Space Station or to the moon, and so they'll end up having variations that will be able to carry larger, more people.
Well, if they haven't sent up like a space shuttle since 2003, like didn't they send something to like other places since then?
Yeah, it's a very good question. The space shuttle actually is still flying. In fact, there will be a launch here in 2011 coming up in not too long. But that they want that to be the last one. They originally said the last space shuttle launch would be in 2010, but they pushed that out a little bit. Okay, feel free to jump in. So I mentioned this company's down in Charleston, South Carolina, and the reason I talk about this story is this vehicle right here has saved a lot of soldiers' lives. And it wouldn't necessarily look like it because it's not the coolest looking thing in the world when you're in it or when you're around it. There's not a lot of, they didn't make it to look good. But what has happened in the battlefields in Iraq and Afghanistan, a lot of our soldiers are getting killed by or hurt by what are called Ieds, improvised explosive devices, which you've probably heard a lot about. And they're just roadside bombs. And you can't really tell what they are. They might, I don't want to be too graphic, but they might put, our enemies over there might put a bomb in a dead animal on the side of a road. And so a truck would go by and hit it, and the bomb would blow up. And the vehicles that we had over there couldn't withstand the bomb blast, and our soldiers were getting hurt. And so there was one scientist, one mathematician down in Charleston, South Carolina, that came up with something in this, at the bottom of this vehicle. It's called a V-hull. So the bottom of the vehicle has a V shape. And for whatever reason, the way he was able to design this, that V shape deflects the bombs, and they have, and since this has been in theater, as they call it, since it's been deployed in Afghanistan and Iraq, there hasn't been a single soldier killed from an IED blast for one of these vehicles. So it's a very simple, it literally is just the shape of a V, but just the way it deflects has saved a lot of lives. And again, it's another example of how a particular design that someone thought of on their own has made a big difference in the world, particularly for the soldiers. So this company makes several variations of this vehicle. This one's called the Cheetah. Yeah, and they only go about 40 to 50 miles an hour, and they are as heavy